Oh, okay. Put that away. So, is everyone ready to get started? My name's Adrian. I've been working for Careflight New South Wales as a developer for just a bunch of boring business information systems, and I was getting so sick of writing the same forms and stuff over and over again, and I couldn't find anything that should make it that made it as easy as I thought it should be. I'm sorry I don't have slides, so you just have to look at me again. Yeah, there's nothing that made it as easy as I thought it should be, so I wrote my own thing to make it as easy as I thought it should be. Now, what does that mean? How easy should it be, do you think? Like, what is the, if you're trying to target the 80% of functionality that businesses need to get their basic, this is your basic business app where, they've shoved stuff in Excel for a while, and, it's the next move from Excel. So it's basic CRUD databases. But of course, it's everyone wants it on the web because that's the easy way to deploy it. Careflight is a lot more distributed now than it used to be. We've got, 4 bases now. We need access to the same database in different places, and we've got instances where concurrency is actually a problem. We've got people logging into terminal server and running Access databases or a custom built Delphi database and database application, and that just doesn't work. So it needs to be distributed. It needs to be easily deployable on the web. It needs to be accessible. And it's just basic CRUD forms. So now I was looking at a lot of the frameworks that are out there. There's Rails is one. I know this is not a Ruby group, so I won't talk any more about that. Django is the obvious poster child for this sort of thing, but Django has some severe limitations that I found. The ORM, the database layer, it sucks. I don't know how long Django's been around, and they still haven't got, in a release, multiple database support. Correct me if I'm wrong. It's coming. It's been coming for a long time. But just that style of, magic static methods on classes to, dot objects just doesn't cut it very well. I looked at Pylons because Pylons seemed to go well with what I was after, something that didn't, reckoned it wouldn't get in my way, but that just seemed to do things in a very strange way. These, I don't know if you've looked at, it's built on Paste, the Ian Bicking package, and it's got a very arcane way of bringing up a running application and configuring it, and it uses easy install setup tools, entry points, and there's this dozen levels of indirection if you follow the code just to hook into where it actually instantiates your application and then starts to run it. So I thought that's not very good. It's got these request local pseudo global variables that that Pylons uses as well, and which just that sort of stuff just rubs me up the wrong way. I think why do you do that? Just if you look at a script that says from Pylons import request, where the hell did that come from? It's this bizarre thread local stacked object proxies that make no sense at all. And then of course it says nothing about how to integrate with a database, so you're basically left on your own there anyway. And then there's things like URL dispatching. You've got to design your own, you've got to say this in Django's great, it's these bloody regular expressions. Parse this regular expression and then go and look up this controller thing. Well, I was having none of that, so I started with Pylons and gradually just got rid of it all. And you know, the use case for me was I've got my own application. There's only one of them. I'm not building something to repackage and hand off to the world like Django wants to do these packaged applications, and Pylons wants to get all these WSGI things and stack them together. No, I don't want to do that. The problem with that was that I ended up writing these ridiculous configuration files when I could I just wanted to write the Python code to bring it up. Anyway, so that's the problem space. I thought it was all too hard. So what have I come up with that's a bit easier? Well, firstly, I've done a little command handler that seems to work the way I want. So assuming you've set it up, then you get this is based on the paste one or whatever, and I've just sort of copied that. So on. So what's this demo 0? Well, that's easy. That's this one. Nothing there. So just to get an app running, that's all there is. Oh, it's all in demo app, obviously. So here's demo app. So there's my app. This is stuff copied from another thing. You don't need most of this stuff, at least not for the moment. And the interesting part comes from in the app. There's a little command suite that collects all the commands and then presents them to you in a little thing. But anyway, the long and short of it is that it collects everything and then runs a server or I don't know if you've seen the paster shell, but it's basically exactly the same thing. So there's my app object. Now instead of these, I'll get into the details later. So, all right, that's not very useful. We can run it, we can look at it, but if I use the right port number with the right path, oh, it's because it hasn't registered anything. There's notice this. When it started, it said there's nothing in the registry. So let's put something in the registry. Let's actually, that's why it's 0. So number 1. This does a, don't know if anyone knows about this meta class trick. If you stick a instead of having all these classes that inherit from object, you can just stick a meta class global variable and you don't have to worry about that anymore. All your classes are new style classes then. It's just a little aside. Everything in here is based around what I call a meta, which is a stupid name, but you can't think of anything better. The meta does this meta class trickery that collects all the attributes on your classes and assembles them and registers them to serve. So the first thing you have to do is create a meta with a registry. Now this demo registry was just created here. That's just a thing that collects all our stuff. We want to create a base class that we can use. You can create a few of these. You're not limited to this particular one. There's various different things, parameters you can pass in this to make it more flexible. I don't know if any of you have used SQL Alchemy and its declarative extension, but the idea is the same as that, and in fact I use that because if you want to use a declarative extension, that uses meta classes as well. So it means you have to actually, if you want to use 2 meta classes, they have to be related in inheritance hierarchy and so on. So you set that to create a class, which now it's all based on model objects, all on domain models. So I don't have to define any views or anything. The framework does most of the views that you'd need. All you have to do is define the domain model. So here I've just started with a simple one that does nothing. You must have permissions. So we don't have permissions. We'll see what happens. unauthorized. Gee, that wasn't expected. But if we say that the view is authorized, then off you go. Bang, there's a view. And it's telling me, because it's just doing a str on the model, that that's my title of the page. I'm not logged in. And there's nothing in it. Great. So we've got it running. But if you want to do something a bit more interesting, let's first make the str do something that we'd like to see. Now here's a bit of code, but it's just, the point of it is just to, because I use these double underscore attributes to configure the framework. I don't really like that, but I can't really think of a better way at the moment. If anyone has any ideas about any better way of doing things, I'm open to any suggestions. This is very alpha and experimental at the moment. So all this does is ignore the key of the model, which we'll get to in a minute. No, you ignore the key, it looks at the key, and if it finds something, then it will do something with it, and eventually it produces a title. Again, we get the same thing. That's our base class, so we want to actually inherit from the base class as our new base. So we'll notice that this transient model is in fact a subclass, an indirect subclass of this, I think. So we set a title. We tell it what view we want. So there's a bunch of view classes that you can reuse, and this is where you plug into the views to add your own screens and widgets and so on. Again, it's public. And for the moment, we'll just look at that. Is that 2? Yes. Surprise, surprise. Nothing there because there's nothing to navigate. However, if we stick our first real model class in there, this little parent attribute attaches simple to home, so that this nav screen knows to look at the children of that model and produce URLs so you can link to them. Some other interesting bits are this is probably the most important thing. We need to tell the framework what the attributes. So it's like a static type thing, but it's in Python. Now these are my own types, and you can extend your own. And this is what the framework uses to do the validations of the forms and to find the correct widget to use. That's about it for that. If I left form fields out, there would be nothing at all to show, because the framework uses these attributes to say, these are the things I want to see on my screen. You can ignore list columns for the moment, because they're not used until the next demo. And then again, permissions. These are just some default values for those attributes that we found. And I guess we could get rid of that. We may as well. Hopefully it won't break. There's nothing there. Why is there nothing there? There it is. Buggy. So there's our link. Notice that it produces a URL to simple. It got the name simple from the name of the class. You can override that with attributes again. So the point of this is you don't have to worry about your URL design. You can it just produces a hierarchy from what you've provided. You can override this with a name. If I were to call that lo and behold, it's hamburgers. So there's our form. It's just a basic form design. It just uses some templates to produce that, and I'll show you the templates later. These labels can be configured as well. If I were to say this date should in fact be called then that's what it says. Is there anything else interesting there? Form fields, list columns. So we can edit that. We get a form. So notice there is this distinction between views and forms. So each model has, if you 0 or 1 views, and the view is all of this and it's read-only. And if you have permission to, you can edit it. Now we can take that permission out and edit disappears. So we can change the name. Here's a nice little date widget. Save a draft. Now this is an interesting, will eventually be automated so that it saves in the background. The idea of this save draft feature, in fact the whole framework, is it stores all your objects as a pickle in the session until you're ready to commit it. Now the reason for that is this date might be required. So if I were to take it out, it doesn't say anything, but anyway, it allows you to save it as a draft and come back to it later, although the come back to it later bit isn't written yet, but we'll get there. The whole saving it into the session works quite well and allows you to save whole trees of objects before you're actually ready to commit them, which is actually quite useful. So if we finish that, we will get bang. That kind of makes sense because we haven't told it to go anywhere. We have, in fact, called it transient. So if we want to make that go somewhere, if we want a storage implementation, we need a few more metas. First, we need this, what I call a DB meta. Again, it's the same registry, but it has a method that says that tells the framework how to get the database. That database could be any object. It just takes a context, and then you're responsible in your meta implementation to return some object that the framework can, this DB meta is actually, I think that's tied to SQL Alchemy, but there's no reason why it can't be completely removed. The other meta we want is what I call an iterator meta, iter meta. Now the point of this is if you've got a collection of, say, simples, you want to be able to see a few of them and pick the one you want to look at. Well, that's the job of an iterator. Maybe Nick can have a better name. I'm not very good at naming my classes. Same model base. Again, to create an iterator, we need to subclass model iterator, which has the appropriate implementation for various things. Again, we create our base classes. The home model is exactly the same. Now here's the interesting part. All we have to do is just attach an iterator between the simple and its parent, and the iterator will know how to do the rest, because this DB meta, which is probably really an SQL Alchemy meta, knows how to query the database. Now this part here is the implementation, storage implementation. This is just straight SQL Alchemy, declarative layer. So if you're not aware, it just the normal SQL Alchemy is a little bit more verbose. You take a class and you define a table and you map your table to your class. This it allows you to do it all inline in the one place. It's just as powerful, and in most cases, much more readable. That's all you need. So let's run that. Simples, name of the class. There's a list of simples because it's just, this is the, where is it? The database implementation here. So notice that my meta, to get the DB, I return some attribute of my context called DB. What is this context? Well, you define a context which provides all the resources to your application session. The idea here is it's a kind of application delegate. The application is where you store all your global stuff, and every request maybe gets a new context. Now the caveat here is the context needs to be serializable, so it needs to be able to recover from pickling and unpickling. That's not too hard to do, but things like database resources obviously need to be reattached. So that's what this app resource thing does. Is it just it's a little just a little descriptor that returns the factory and basic stuff here. How does it get deleted? I forget. Anyway, it doesn't get pickled. There's no need to worry about that. You register your context with your application. I'm a demo context, blah, 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 blah. And the global states here, we configure a SQL engine here. I'm just using, it's from a config, so let's show you the config, I suppose. Just basic ini file, and down here we just do that. That's SQL Alchemy has a little routine that knows how to read this. Metadata.bind, because all this this allows you to just in fact you don't even need to do that for most cases. It's just if you want to create tables or so on. You can leave your metadata unbound for most of the this metadata is an SQL Alchemy metadata. This is what collects all your declarative table structures into tables, and then SQL Alchemy knows how to dispatch queries according to that. So context or DB, get DB, blah 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 blah. I don't know if I can show you the implementation later. But I'll do for a moment. Any questions? Yes? I suppose I haven't looked at it in depth, but the principle is the same. It's a declarative ORM layer. The difference is in Django, I don't think Django separates its own type information from its database implementation, whereas this clearly does. As I showed you, you declare your types to the framework, and it's completely oblivious of what the storage is. And then only this is the implementation. So it allows you to create models, for example, for LDAP objects or for session objects or anything like that. Transactional forms, yes. It's very transactional. I'll show you. To the database transactions?
Just to application operations. If you've got a database, database abstraction, but one thing you want to do with frameworks,
Oh, okay. Okay. Yeah. The transaction is handled in the view, because now I know that sounds like I forget the word. Heresy. That's the word. But when you think about it, the view is the only thing that knows what's going on in the user's interaction. So it's responsible for taking, well, firstly, for binding the handlers to the thing and then knowing what to do. So the control, I mean, this is a kind of model view controller thing, but the controller is the framework. The view is 80% of the views are the framework, and then you plug in the rest of what you want, and the rest of what you do is all models. So I can show you the so here's the form screen, bind, edit. What we want is finish. So when you edit something, there's a button called finish, as you saw. So finish is the one that's obviously going to commit your transaction. So you bind do finish, and down here it says called commit model, and then returns the next action to finish it. And commit model down here with self.context is your transaction handling. Now that has to be there because further down the stack you don't know what the transaction boundary is. The transaction boundary needs to be as high as you can do it, and so if you want some transaction at a higher level than that, you've got to write your own form and bind your own form handler to handle that. And that's quite easy because all you have to do, as you can see, it's just a simple API call to store model, and the meta knows how to do the rest of that. This just says, okay, this is now a transaction, time to commit, thanks. Does that make sense? Say again?
It is clear, but you've just explained that.
Okay. Yes, we'll get to more of that later on. I'm starting from the... I'm sorry if this is a bit slow. I'm starting from the... I thought whether to start from the the user end or the developer end. The user as a developer of thing rather than developer of the framework, because it shows you how what I'm trying to get at to produce the framework. There's a lot of back end stuff that's all very interesting, which I can talk about later on. Any other questions? Yes?
Do you have to define a subclass or those measures? Is there a shortcut for that?
You only define them for each type of implementation that you want. So if, for example, in demo 2,
all of them seem to be empty except that they're looking at the registry.
Yes, yeah. So this is all you ever need to do if that's the extent of your storage implementation. And in fact, I can show you my current one, which is pretty much the same thing.
I mean, how would you customize the iterator method or whatever?
Just by implementing those API methods, the store model, load model, create, construct model, and so on. And I can show you. So this is mine. I like some compile time checking. So because meta is a meta level, it's meta programming. It's all done at the first pass through your program. I like a bit of static checking. So although I actually don't do any, but I intend to. First thing I want to do is verify my model. Then I want to actually register my table. And I've also got a bunch of stuff where I can create and drop the tables and so on. So here is a good example. Because SQL alchemy allows different forms of polymorphism and polymorphic hierarchies, your method needs to plug into that to get the right class. So instead of me saying, my SQL alchemy mapper, please give me the correct class for this key, I've actually this is just the implementation of that. And the rest of it's all just much the same. That's the idea of that. Okay, going on. All right, so this simple one, we said the key was ID. That's a basic kind of key. It's just an integer. SQL alchemy, when it creates this table, deals with the sequence business, or you can add that explicitly or whatever you like. The only point of that is that the framework knows, based on this, how to create a URL for a particular object, and then how to take one of those URLs and turn it back into an object. So notice that over here, this one's just number 4. Now, this is where I get a bit opinionated and say that this is where, and URLs really they don't need to. Well, the first point is that URLs don't matter for most people. No one looks at them. It just doesn't matter. The other part is that there's no need to over-design them. Given that to instantiate one of these models, all you need is the name of that model and some 0 or more arguments. Well, the structure of a URL is basically name of model, 0 or more arguments separated by slash. The slash is supposed to be configurable, but I can't really see much point in making it configurable. It's just, anyway, it's not a magic value. Now, what if you want more than one attribute to be a key? That's possible. Not only is that possible, but the key doesn't have to be a scalar value. So if we look at, let's get rid of that. So extending this further, I'm going to create a class called complex. It's called complex because it's made up of simples. And in this case, the key, now this key just names attributes. This key has 2 attributes, is made of 2 attributes, and those attributes are of type simple.
So this is a composite rather than key?
Yes.
Because that's where Django falls down.
Doesn't it?
It doesn't.
Certainly where Rails falls down. Yes, you can have arbitrarily complex keys.
You can use a composite key to get to a table, but it can't be your primary key. So but if you've got a natural composite key, it'll put some awful serial number down the side.
Yeah. So the funny thing about that is, I've just doing my model. I've been trying to do, proper database modeling with correct natural keys or whatever. Found that there's a few issues with SQL alchemy with cascading updates on primary keys, and maybe I shouldn't really do that. Even though SQL alchemy supports it, this supports it. I did figure that things are going to be a lot simpler with surrogate keys, but I'm either or. Now, in this case, I'll just have default permissions. We won't worry about that. You've all got the idea of what permissions do, right? It's pretty basic. The interesting thing about permissions is that not only can it be public or authenticated, you can have. There's 2 other types. There's static, which whether you pass it just a list of, or actually a whole expression of. No, that comes later. Static, which is just a privilege that your user object must have, or it can be dynamic, which actually requests the model that you've loaded, whether the current user is allowed to do anything with that operation. And because those access objects are actually completely generic, and it turned out to be really simple to just stick use them for the types, the type annotations, and for the field generation. So I can stick them in here. I could say name is well, I'm not logged in, so it's going to stuff up. But you can say that each attribute has a permission, and then, or it can be completely dynamic. Anyway, moving on. Complex, two simples, form fields, simple, simple again. This is just our implementation. It's a bit complex because the SQL alchemy definition of this relation requires you to specify the primary key, because there's actually two foreign keys on that table. If they were, like, you wouldn't often actually have two simples or two of the same type. You'd probably have two different ones, in which case SQL alchemy can quite easily infer the correct join, assuming that you've got the correct foreign key set up. So let's have a look at that. Simple's still there. All very good. Easy. Just shows you that stuff. It knows where to get this. It just this is what the DB meta does. If you want to define different methods of getting these lookup values, you can filter them in various ways. That's possible as well. Yes?
How easy is it to change the drop down to a different widget, say an Ajax search form?
It's supposed to be very easy. That's what I'm working on now, and I can show you that towards the end. I can certainly show you some more complex widgets. So that's a complex model. Not so much more there. Next one. What do I do here? Oh yes.